Okay, stereographic projections on the origins of the astrological clock in relation to planispheric astrolabes. Stick around to the end of the video if you've always wanted to know more about these. The astrological clock transcends the mere function of timekeeping, embodying a profound synthesis of astronomical and astrological knowledge combined. Its conceptual foundation is deeply intertwined with the astrolabe, which is that sophisticated astronomical mechanical calculator of immense historical importation. The astrolabe is derived from the Greek terminology astrolabon, meaning star taker. It epitomizes one of the most advanced and historically pivotal instruments in history. This zodiacal apparatus exemplifies the harmonious convergence of scientific innovation and artistic craftsmanship. This ingenious instrument facilitates a multitude of celestial computations, including the determination of the sunrise and sunset times, the hour of meridian crossing, the altitude of culmination, the azimuth of the moon and sunrise and sunset, right ascension and declination, among other parameters. It's an invaluable tool. The astrolabe's invaluable utility lies in its capacity to procure high-precision astronomical data independently of modern technology. You don't need any type of technological equipment to get this type of data. So it's akin to the precision obtainable from contemporary space agencies such as NASA. It's equivalent to getting data on the same level as NASA. So the true significance resides in its ability to project the three-dimensional celestial sphere down onto a two-dimensional plane, thereby enabling users to visualize and comprehend the great cosmic celestial expanse that envelopes our reality. And absolutely central is the firmament, which is the celestial sphere, that's the sky, while the Earth remains a flat dielectric inertial plane. The Earth is still flat. The representation is achieved through what is called a stereographic projection, wherein the spherical sky is depicted on a flat surface, and specifically an azimuthal equidistant celestial spherical sky encircles the observer, and with its projections, it's captured on a flat plane. And so this process results in a three-dimensional projection being holographically etched onto the two-dimensional surface. The disc up top is called the constellation disc, and the base plate is the chronological disc, allowing observers to determine the current constellation in which the sun is located without any technology, enabling the determination of the calendar date by correlating the sun's position on the analemma. Now, as you can see on the image, the central sections of the image highlight that every zodiac section on the dial represents a month. And this delineation underscores the division of the ecliptic plane into 12 equal parts, each associated with a specific zodiac sign, and therefore facilitating the tracking of the sun's annual journey through its constellations. And furthermore, the image elucidates that each smaller segment within the zodiac sections corresponds to a span of 5 days, as it says right here. Okay, so this granular segmentation permits a more precise temporal measurement within each month, allowing for a detailed chronological representation. Now, this clock was based on a geocentric model, but over time, people have perverted it to be heliocentric. And the planispheric astrolabe employs the stereographic projection to project points from the celestial sphere onto the equatorial plane. Geocentrically, with the Earth at the center, gradations of color on the clock signify different times of the day, ranging from orange hue for the dawn to the uppermost blue for daylight. Throughout the day, the wand representing the sun aligns with corresponding colors. For instance, the astronomical night is the period when the sun is 18 degrees below the horizon and no twilight is present. And then daybreak and twilight intertwine. The first appearance of daylight in the morning marks the end of the astronomical night, along with twilight is the same thing, the period marked by the presence of diffused sunlight in the sky. And then you have the outermost numbers along the outside set against a black backdrop. These are the old Shizek time, or the Italian hours, also known as the Bohemian time or the Babylonian time. The outermost timekeeping system features numbers from 1 to 24. It starts right here, there's number 1, and it goes all the way around. Okay, so from 1 all the way around to 24, the 24 signifies the hour of sunset in the Babylonian Bohemian Zizek time. The dial of the Bohemian hours turns daily so that the sun hand points to the 24-hour mark at sunset, with the rotation angle depending on the sun's declination and the daily radial measurement of its celestial arc. Conversely, the time familiar to us is displayed just beneath it. You have the outer and then you have the inner right here. So just beneath is the inner ring, which is the Roman numerals indicated by the standard 24-hour Central European time, which corresponds to Prague's local civil time. So at first glance, the clock features 2 dials, with the smaller one at top and the larger one is below. You have 2 separate wands representing the sun and the moon that traverse the zodiac ring on the top. The sun wand moves counterclockwise against the ring, indicating the positions of the sun and the moon in their geocentric orbit around the earth. And these depictions of the clock are analogous to specific representations of the geocentric flat earth model. The moon wand is half white and half black to display the current phase of the moon, which would be a half moon. So just like how I've discussed previously in other videos, where the black sun's excitation angle is what is responsible for the angle of the conical refraction that creates the sun and the moon, and that creates the phases of the moon. We see the same constitutions with the constellation disk on the top in determining the position and the phase of the moon relative to the sun. This celestial mechanism allows observers to gain insight to the moon's current constellation and its positional difference relative to the sun's constellational position. There are 4 primary lunar phases: new moon, full moon, first and last quarter moon, and each phase is characterized by a specific angular separation between the sun and the moon, as represented on the constellation disk.